All right. Welcome, everybody, to our first TWed of the fall 2020, unfortunately, COVID season. Thank you, everybody who's joining us in this WebEx or joining us via the recording. Just a couple logistical announcements. Number one, thank you to those who have already signed up for future TWEDs. We have TWEDs on the schedule for the next, I think, at least 3 weeks, and several people, graduate students or staff, who have agreed to do TWEDs or idea community talks for the rest of the fall term. So we should have a full slate starting this week. Um, we are recording this, and it will be posted via the Tetherless World and IDEA websites. So please keep that in mind when you ask questions or make comments, that sort of thing. For logistical reasons, it's easiest if our speaker, Henrique Santos, can just does his presentation and pauses occasionally if he wishes to ask solicit questions. He'll ask for him. It's a little bit easier than interrupting him with questions. If there's something important, I will be watching the chat. I encourage Henrique not to be watching the chat, but I'll be watching the chat, and if there's an interruption that needs to be made, I'll go ahead and do that. All right. So without further ado, we're really excited to have Henrique Santos lead us off in giving us some kind of a talk related to the Common Sense Reasoning Project. Take it away, Henrique.
All right, thank you, John. So my name is Henrique. I'm a research scientist at the Tetherless World at RPI. So this talk will be about our efforts on supporting the integration of structured knowledge in those question answering systems for common sense. Let me go forward. So common sense reasoning, what is this about? So we have systems that at least they are try to be able to correctly answer common sense questions. These questions are usually very easy for a human to answer, but they are very difficult for machines, or might be very difficult for machines. So one of the reasons is that because the answer is not present in any database, that means that you cannot apply approaches that are usually done in question answering, which is like translating the natural language question to some structured query, and the query some database that will return an answer as desired. And this is due because to answer common sense questions, you need to use common sense knowledge, potentially together with some kind of reasoning, right? So, for instance, you have this question over there. What is the result of applying for a job, right? So both of these answers are plausible answers, like anxiety and fear, and being employed. I believe for most humans answering the questions, being employed would be a better choice than anxiety and fear. But if you think about COVID, unemployment, maybe anxiety and fear should be a better option. But yeah. And also the second question, the man was going fishing instead of work. What is he seeking? So either food or relaxation, right? In normal terms, relaxation might lives in the woods during the pandemic and everything is shut down and he's looking for food, then he might be getting food instead of relaxing, right? So this project is conducted under DARPA's Machine Commonsense Project, which the Information Science Institute at University of South California is one of the prime grant holders, and we are under them. And the DARPA's vision of this program is to have a machine common sense as a computational service that you can just ask common sense questions and get answers, right? And they have two approaches for that. One is a service that learns from experience, like a child. So you present the service some real world things, how it works, how it works, what happens when you do something. So it learns, and then you are able to answer questions from experience. And the second approach is a service that learns from reading the web, like a librarian. So you read out from documents or some kind of structured knowledge, and you also learn. You are able to answer questions out of that. Okay, so the story so far. So these common sense QA systems, question answering systems, are largely based on neural networks today. So many that we have researched, they are based on this kind of networks, like graph convolutional networks, opinion comparison networks, long short-term memory networks, and more. And because of the nature of these approaches, they need to use some kind of language encoders. So that means that they are also largely based on language model, and these include BERT, RoBERTa, ExelNet, GPT. So those are encoders that provide a number of NLP services, like tokenizing, word distribution, and so forth. So the language model output can be fed into these neural networks, right? So right here you have some a very minimal pipeline of these systems today. So first you train these models with a set of questions and answers, and you pipe that into some language model, as seen above. The output, you pipe that into a neural net that learns, right? And then after you train your model, you can prompt with some new question, and that tries to guess the correct answer for that, right? And then you have some kind of scoring. Okay, so to evaluate how good these approaches are, we have the so-called benchmarks, right? So these benchmarks are basically data sets usually composed by training, development, and test data sets. The test data sets are usually not available for the developers, so they are not biased when testing their system. So usually the training data sets are provided for you to train your system. You then can use the development data set to test how good your system has been trained. And after that, you submit your system to some kind of authority that is able to execute your system against the test data set, which is hidden from you, and be able to see how good it performs against the test data set. The idea is that if your system is doing good with the development data set, it should be good as well in the test data set. These benchmarks, they can have specific thematics like social interaction or how choose or more, or just be general purpose, common sense knowledge. And the structure, so some provide, or many provide just questions and answers, common sense questions and answers. We have one that we researched that provides observations of the real world, like it tells you a little scenario, like an interaction between two people or whatever. And your system needs to to select the most appropriate hypothesis to explain what's going on, as described by the observation. Another one is goals and solutions, which is more kind of a how-to. I want to do this. How do I do it? And you have possible solutions for that. And you have more appropriate solutions than others. And the goal of the system is to pick the most appropriate one. Right? And we have more in addition to that. They also provide different levels of information the system can use to train itself. So we have a benchmark that provide question types. So the system can leverage that. So it's a true or false question. It's a capabilities question. It's a counterfactual question. Something like this. Some provide the required type of reasoning, like this is logical reasoning, this is temporal sequences, this is theory of mind, and so forth. And some benchmarks are automatically created from structured knowledge, and these might provide to you the concept they originally used to create the question. So this information can also be used by the system to be better trained. Let's put it that way. Okay. So these leaderboards are hubs for hosting these benchmarks, and they accept system submissions. And they execute those systems against the test data sets, as we told before. And they keep a ranking of which system is doing better, right? So this leaderboard, they usually require system submissions to follow some structure. They require either a CSV file or a Docker image with your system. You need to follow some guidelines on how to execute the system and how to present the answers your system obtained, so they can be easily integrated with the test data set and ranked. And they usually provide the accuracy of a human answering a specific benchmark. Here we are seeing the Cosmos QA 1, which is 95%. When a human tries to answer. And we have this unicorn system being like almost human performance, like 91.79%. Right? So they keep track of how well the systems are doing against the specific benchmarks. Right? Okay, the original RPI job in this project was to maintain and augment what we are calling the common sense knowledge graph. So we had already many knowledge graphs in the web that could be considered common sense. The most famous of them is the ConceptNet, which is, I believe, over 15 years old now. It's basically a set of concepts linked by some limited set of properties, like is related to, can be used for, stuff like this, right? And we have integrated a number of other knowledge graphs to that graph. So you see WebChild, Atomic, WordNet, VerbNet. Those are all being integrated and maintained by us. And ISI as well into what we are calling the common sense knowledge graph. So one of the ideas is that if we have this kind of common sense knowledge in a structured way, in this case as a knowledge graph, knowledge can be used by these question answering systems. The hypothesis is that this can help these systems to get better performance against these benchmarks. Right. This is the great hypothesis of this project. So the idea, how do we support this? How do we provide a way for the developers of those systems when they're trying to incorporate this kind of graph into their pipelines? How can they somehow measure how their systems are doing with this with the incorporation of this knowledge, right? So we have thought some things we could support and what can we do. So we wanted to allow developers to analyze existing systems and verify if the system is failing in a specific type of question. The other thing was if the developer finds that some type of question is not doing very good, can he find new questions of the same type and prompt the system again to see if this is indeed a trend of being not very good at that kind of question. And the other ones was to allow developers to understand how their knowledge graph approaches are doing. Like, are you grounding your natural language questions to terms in the graph? How this is occurring? How are your groundings doing okay? So the other thing is, are you calculating paths from the concepts in the questions to the concepts in the answers? How this is being done? So we are also thinking of those things and how those things could connect to help those model developers understand how the knowledge is being used within their systems. So the first thing we did was to analyze the DARPA benchmarks for the first year of the project, and I believe this list contains all of them. I think they are. So we analyzed them, and those are the constructs they have. So basically, most of them are questions and answers, but some, as we discussed before, so physical IQA, you have goals and solutions. You have ANLI with observation and hypothesis. Cosmos QA, in addition to the questions, you have a passage stating the context of the question. So you might have a question that you could have some answer, but it's somehow contextualized, and the answer might be different to what it should be, right? And the Hello Swag, you have a context, and you have what's going to happen if you have this context. So you have what this benchmark call ending choices. One of the things the year one benchmarks have is they're all multiple choice or true or false in the case of psychic. So you have a closed set of possible answers. You don't have open-ended questions. So you need to pick one of the presented choices, like A, B, C, D, E, or A, B, C, whatever the benchmark requires you to. One of the interesting benchmarks is Psychic. Although it has received a lot of criticism among the project's participants, it contains some kind of useful information, which is these mostly these categories construct. So it explicitly defines the category or the type of a question. So this question is logical reasoning, or this question is object properties, or this question is arithmetic, stuff like this, right? So this categorization is something that we believe we could use across benchmarks to be able to normalize queries and retrieve additional questions when analyzing the systems.
Henrique, could
Okay.
I interrupt you for just 1 second? Go back to that
Sure.
slide. Could you just clarify, where are the benchmarks coming from? Are those coming from DARPA? What is the source of these benchmarks? And
Right. So I believe physical IQA, social IQA, ANLI, they are all from people from within DARPA's projects, from a number of research groups. Common Sense QA is not an actually DARPA benchmark. They are created outside of the scope of the project, but they are common sense. And they have been used to test the systems developed under this project as well. So a quick answer, they are created by research groups just like us. So they have different approaches to create them. Some they use are derived from ConceptNet. They try to find paths in the graph that you can transform that path into some kind of question in natural language with possible answers that challenge the systems. For instance, Psychic, they have their own graph, the Psych graph, and they have some kind of questions templates to be able to generate those questions. Psych is a company, no? You probably know that. So I think the answer for a question is people working on that, they are creating this, right?
okay, great, thank you.
Research groups like us, not only under DARPA, most are DARPA, but not all.
Yeah, so there's some of the big players. Allen AI Institute, for example, is a giant player in this space, and Psych, of course, has been around for decades. So it's a range.
Yeah, and Psych is part of the project as well, right, Deborah?
Oh yeah, both of them are part of the project. Yeah, so both Allen Institute and PsyCorp are part of the evaluation team, but not all of these are developed by entities that are part of the evaluation team.
Yeah, I think Common Sense QA is not, and I think HelloSwag is not. I think the other ones are within the project.
Right. I think so too.
All right.
Okay.
Okay. So to be able to support those questions that we have put, we created this common modeling to be able to integrate those diverse structured benchmarks in a way that they could be normalized, let's put it that way. So to do that, we have used as higher level classes the schema.org, which we thought would make sense in this case because those things are basically data sets on the web. They can be discovered, they can be reused. So schema.org is very good for this. There are a lot of companies, Google, doing that for you. So we thought that would be a good choice for this specific scenario. And we have extended this into specific classes. So we have a benchmark and we have a benchmark data set. So usually these data sets are the training data set, the development data set, and the test data sets. Within each data set, we have what we're calling samples, which are each specific question or whatever you have there. For each sample, you have some inputs, and these inputs can be questions or observations or context or goals or some kind of category types. The benchmark gives you to train your system with, right? So we have specific definitions for these kind of things, right? but they are all inputs. We're calling these inputs. And you have a set of choices, of possible choices for this. Right? These choices can be hypotheses, answers, solutions. These are based on this mapping that we have done before. Right? And when you submit a system that tries to answer a benchmark, you have a submission, which is a data set as well, like a CSV file, for instance. And you have a prediction, which is the answer your system is trying to, the question your system is trying to answer. So this is also linked, this links to the original benchmark where I'm trying to answer this question, and I have my choice guess, right? So as you can see, we have transformed this diverse structure in a normalized schema that can be used to integrate these diverse benchmarks and to facilitate queries and so forth. So this is this is not an actual architecture, but it's more like a pipeline that we are doing right now. So here we have the benchmarks. We have some systems we have worked with, like CAGNet. Those are QA systems. We have a converter. This converter has been initially developed by Jason and is now being developed by Gretchen. This converter uses these original benchmarks together with the ontology to be able to generate a common JSON-LD file that conveys the same information that it is here, but in that common format. Once we have that, this is fed into the MCS benchmark browser, which was developed by Miner, the current version of it. And we are able to visualize those benchmarks together with the output of these systems to be able to do some sort of analysis of what's going on with the systems. This is just an example of what this JSON-LD looks like. So basically, you have some, I'm showing an example, a question here, a specific question. So you have the actual question here. I'm using the terms in the ontology to classify this question as a benchmark question, as you see here. Social IQA also, in addition of the question, have a context, right? Also in natural language. And you have the possible set of choices, right? And you also have the correct choice, right? If you know the correct choice, this is probably coming from either the training. Oh, it's the training, yeah. It's the training data set, right? Okay. And this is one of the screenshots of the benchmark browser, which I plan to show running. Okay. All right, so let me go back here. Okay, so we have the benchmark browser running, and we have loaded using this pipeline a number of benchmarks. I think this 4: Psychic, Commonsense QA, Social IQA, and Physical IQA. So if I navigate here, you can see the benchmarks that compose Commonsense QA. You can see the number of data set contains. And we also can see some submissions against these benchmarks. So for instance, let me go here first. Commonsense QA. We can see all the Commonsense QA development questions. And you can see how those two submissions are answering this specific question. So for instance, these questions over here, a revolving door is convenient for two-direction travel, but it also serves as security measure what? So CAGNet got the correct answer, but Roberta did not, right? If you go to that specific question for that specific submission, you can see the usage of the common sense knowledge graph when trying to answer that specific question, right? So you can see that the right question was the right choice for that question was bank, right? And you can see here the path that had the highest rank when used to answer the question. So you can see here door related to doors, which is related to bank, right? So that was the path that won during the execution of that specific system over the specific benchmark. You can also see here the other question, the other answer, which was library. So that had a lower score than bank. So that contains the path that for door to library and department store. So you can visualize this and see how your system is using the common sense structured knowledge in trying to answer these benchmarks. All right.
So is part of this in terms of the ranking of the potential answer nodes? Is there something like a page rank being used to sort of initially order those and then applying the matching to that?
It depends a lot on the implementation of the system. So I know that some systems are doing some kind of attention score, which in conjunction with language model is able to tell the best path. So I don't think it's kind of at least I haven't seen anything about like something like PageRank. So it's more like how in conjunction with the language model, how likely is this concept to be the concept they're talking about, right? Because the language model is kind of a distribution of words. And it's more on these lines instead of just regular PageRank.
Sure. Okay.
Yeah, but it depends a lot. So if you go to these systems that are using graphs, they use in a number of different ways. So some calculate graph embedding, some do not. Some uses the knowledge graph just to ground the terms during the natural language parsing, and that's it. So it depends a lot how they are trying to use the structured knowledge in these pipelines. All right. So, yep. Yeah, so I forgot to put the next steps over here. So I'll just say the next steps before I talk about this. So the next steps in our work is to basically move benchmarks to the year 2 benchmarks, and these include a lot of open-ended benchmarks, which are not based on specific choices. You can have open-ended questions. So we are starting this work. We intend to further work with the model developers to see what kind of analysis they want to accomplish. So what we did so far on here was basically Jason's work on reverse engineering those systems and trying to output whatever information he could find. So we are not so far working directly with the model developers. So we are basically showing you what we can do and how they could reuse or what they want to see in addition to that. Yeah. And
So on
go
that,
ahead.
on those objectives, and this goes back to the stated objectives before, is the idea to try to help the model developers understand where their models are falling short and where falling short in terms of knowledge, and where the uh, better use of knowledge, the knowledge graph in support of that, um, would be helpful. Does that kind of get at it?
Yeah, that's basically the main point. Yeah.
And so what the point of the benchmark browser is that it helps highlight exactly how it's kind of an explainer, right? It helps explain how the particular models are falling short, how they're actually missing the target.
Correct. And I believe this is explanations are one of the objectives for year 3 and 4, if I'm not mistaken,
Okay.
of this project. Yeah.
Well, right, ultimately, but it's important up front.
Yes, correct.
To see exactly how those models are doing and missing the target. To kind of, it's a form of explaining, but it's more like exposing that, or browsing, as the name suggests.
Correct.
I had
Correct.
a question about the particular visualization that's used in the browser. Those is this form of graph visualization? Is this something this looks kind of novel to me? Is this new to the people on the that are working in this domain? Is this something innovative that we have introduced? This is very cool. It's very intuitive. At least I think it's intuitive if I'm understanding it.
Yeah, so they are very used to ConceptNet browser, but ConceptNet is browsers more for browsing the graph. And this is more to see the paths that matter to you, right? Instead of the whole graph. So yeah. So I don't know if Minor wants to talk a little bit more about this, because he was the major developer of this together with Joshua.
He's not unmuting. But this is showing what it actually did. This is not also showing what's correct, right? Is this
I'm unmuted now.
okay? Go ahead, Minor.
I had to flip my screens around. Can you
Okay.
restate your question?
So my question, well, it started off kind of generally about this particular graph, this particular visualization, but I'm curious about um, the insights that it provides, and what it is showing and what it's not showing. It looks like it's showing what this particular solver did. It's not necessarily showing what the path to the correct is also, is it?
The path to the correct is...
It's showing the path to what it did, right?
Oh, but it is the correct.
Oh, it is the correct. Okay.
The bank is the correct answer. If you scroll up, Henrique.
Okay, I thought he actually clicked. So if you click into a wrong answer.
Yeah, so it's showing the paths to all answers.
Okay, but it's
So
not showing
what this particular system is doing is it's finding anchor words in the questions and then trying to build paths from those anchor words to the word answers.
Mm-hmm.
And that it's essentially treating the paths as a classification task.
Right.
So it's not even really considering the predicates, the edge types. It's just looking for what constitutes a successful path, more or less.
Just the path. It's trying to get there. Okay.
Well, it's not a pathfinder. It's calculating all paths and then feeding them into a neural network.
Okay.
To get those weights, which is what you see there on the scores there. I mean, it's a little bit more complex than that. Jason would have to explain how the system works, but that's effectively what it is. It's taking all paths and between the question and the answers and scoring them all. So what the visualization is showing is it's emphasizing the top score of all of the paths between the question and that particular answer for each answer.
So so what Henrique didn't show is if you scroll down that table, you're going to see the different, not that big table, but you've got something highlighted right now. You've got the thing with the score 0.0734. Are you able to? Now I'm really confused because I see. Stop moving around.
So there's multiple starting nodes, and that's what you're seeing as well.
So what we're looking at right now, okay? So we've got the one thing highlighted, and stop moving around. Is that zooming in on what we had on the left before?
So there's one D3 visualization at the top, which is all answers, and then there's other ones. There's for every combination of word and answer. There's so you see door to bank, but there'll be another word to bank as well. So for every combination of question, word, and answer, there's another graph. That's why this page is so huge.
Okay, so what I'm trying to understand is exactly what we're looking at right now. Okay, so we've got this table on the right with, and we've got the top one highlighted. That one's the highest score, and then we've got the visualization on the left. That is visualizing the highest scored one.
It's visualizing the highest score one, and the things that are faded in the background are the others.
Okay, got it. I got it. So why is that score that's shown 0.8 different than the score we have on the other side?
Because the cumulative score of all of the paths is different than the individual score of the paths.
Okay, so that's cumulative. And
yeah, I don't think it's a straight sum, but it's some sort of combination of it.
Okay, but so very crudely speaking, the line that you've got, the path that you're showing is that 0.073 score. But
yes.
The whole that you've got captured by the visualization is the 0.81. Okay.
Yes. 20 paths you can see there to the right of the 0.1818 score. So
okay.
It's the sum of all of the paths that are in the table there, from door verb to bank verb.
So I should open this up. Do other people have questions? Because as everybody knows, I'll use up the rest of the hour asking questions.
Actually, I have a question to you, John. Is there something that you can think about either in real time or in follow-up that would make this more understandable to you?
Well, there's so I thought I had a mental image as Henrique was going through, and I don't think I was that far off. So prior to this, we saw for a particular benchmark, we saw the results for different question answers, right? We had the column with the CAGNet answers, and we had the column with the other one.
Yeah, which is also here.
Okay, so what I was interpreting as you were going through is that you were actually like clicking on, you were like interrogating a particular question answering. and you were going to explore that in depth. I think that's roughly correct, right? That's pretty much what it is. What was hard, what I got sort of right in my brain was then exactly what we were looking at. But what I was thinking we were also going to be able to see is how something got it wrong. Okay, so if you go back, can you go back to that table easily? The table, you know, where you've got the right there. Okay, so Roberta got the revolving door wrong. The first question, or the farmland one. Okay, so my question is what I would assume we could do is drill in and see how did Roberta answer that question, and then the model developers want to know what knowledge was missing from Roberta so they can get the answer right. That's the whole point, right? That's what we're trying to help them do, is that.
Yeah, or missing or being wrongly used, right?
Well, yes, yeah. The model is missing some utilization of knowledge. That's what we're trying to do. So can you view why Roberta got that answer wrong? Can we see what Roberta did, or well, I guess we see what Roberta should have done, right?
Yeah. So the whole challenge of this is what's useful information, right? We are as I think I said before. So Jason worked with CagNet to be able to find these paths. So before. I think CagNet uses the attention score that I talked about before. So based on that, he was able to retrieve this information and output in a file, because otherwise the models really didn't care much about keeping track of this, right? And we use that because let's see what's going on with the graph, right? As they are using a graph. But we are still missing some requirements coming from the model developers as I see it, right? So I believe we need to increase the collaboration with them to be able to get some specific analysis or queries that we could be providing with this that could be useful to them and to people.
So are they actually using it yet? Is this? I assume the plan is to get this actually into their hands eventually, right?
Yeah, that's the plan. Both
Yeah.
these and the ontology, we believe that the ontology in the future can be used as a way of integrating benchmarks and submissions in a single vocabulary, and maybe in the future have these leaderboards use the ontology as the common format for receiving the submissions. But yeah, we would very much like this to be in the hands of those model developers, and they would output what they want to see in this common format as well, so that could be analyzed in a tool like this, right?
So the other question I had, and this is kind of addressing your question, Deb, in a way. And it's the reason I asked the question in a different way before. This visualization, for the graph visualization, as I understand, Henrique, this is like a subset of what the concept map visualization would be, right?
You mean right here?
Yeah. This is just a bit of it.
Yeah, it's just the path that it found. Yeah.
Well, so my point is, part of the usability is presenting people with something that they're familiar with, and so I was kind of curious if we were introducing something totally new, and if so, how are they reacting to it? Or if it is familiar, are they reacting with some, the pattern matching, no pun intended, to it? So are there other questions for Henrique?
Sure. Thanks, Enrique, for the great talk. This was very informative. So I was just wondering if any kind of reasoning is going on, or it's just kind of more network shortest path type stuff. And if not, where do you see like owl semantics being able to help find better answers to questions and stuff like that? Can you talk to that, Enrique?
Yeah, so as far as I know, there is no system using either some kind of description logic to do this. They are basically doing neural networks, language models. When they use some kind of structured knowledges like this, they just try to find paths, create some embedding, graph embeddings, stuff like this, or use for groundings. We also had this hypothesis that if we know what kind of reason is needed for a specific question, we could be introducing some kind of actual reasoning in these pipelines. But so far, the benchmarks most of times they don't explicitly expose that information. So you need to, I don't know, the best approach to do that. For the year 2 benchmarks, I believe one of them is called Numersense, which is, I believe, more related to arithmetics, and that could be one of the things that we could try something different than just applying neural networks and language models. Yeah, it's a difficult question to answer, actually, because we are not actually actively developing these models. So that's an answer that basically what I am seeing so far from people that are developing these models.
Sure, thanks.
Sure.
And one of the surprising and somewhat depressing aspects of this program is the language models are doing a shockingly good job at answering the questions for the benchmarks without really any evidence of reasoning or even much background knowledge. So one of the reasons we started this work is trying to understand what the benchmarks were actually testing. And another reason we started the work is if we could identify that there was some kind of gap in these language models' ability to answer questions just on a language model, whether we could fill that by adding some triples or certain kinds of knowledge into the common sense knowledge graph.
So that's super interesting, Deb. On the first point, is the issue that the benchmarks aren't actually demanding enough?
Yep, that's definitely true. And,
Yeah.
and in multiple choice, it's easy to do your testing with multiple choice, but of course it's not very reflective of the real world. When I ask you a question, I don't usually give you multiple choice options. And the multiple choice options, there's a lot of gaming that can be done, and these language models are, you give them training data, and even without training data, if they've got the tricks, they're doing a great job, which is one reason why they're expanding the types of benchmarks in the next year. Another reason they're expanding the types of benchmarks is because Dave Gunning started this program and then he promptly retired the day after it kicked off. But he set these targets, and he had targets for like year 2 and year 3, and I think the language models hit the year 2 targets partway into year 1.
So
I'm not sure whether I've got the exact numbers on that, but
So-
they hit the far out targets way earlier than anybody expected.
so this is going to sound like a weird question, but so First, it sounds to me, another way of saying it is the language models are encroaching on the knowledge models, in one way, right? That the fact that the language models do a very good job without augmentation by extended knowledge models, there's embedded knowledge inherently in the language models. Can that be mapped? Can it sort of be? Is it possible to sort of clarify, to define, and kind of, I don't, the right way to say it is define what knowledge is in the language model, and then figure out what knowledge isn't there. And I guess that I may be just restating what the problem is.
Well, only kind of.
Yeah.
So the language models, basically there's a bunch of vectors in there. And they get to look at a whole lot of existing text. So
Yeah.
trying to understand what's really in the language models, I couldn't
Yeah,
articulate
no,
that.
you're right. It's a kind of a black box. Right.
Yeah, Jason's looked at it more than anybody else on our team, and I don't think he could articulate it.
Yeah. He looked in, and he looked into the box and lived. So, all right.
So it was less about what's in the language models. What we really wanted was some characterization of the places that the language models were failing.
Right. Yeah.
And that has been kind of elusive.
Right. So, are there other questions? We're getting towards the end of the hour here, but it's been. Are there other questions for Henrique? If not, thank you very much. Let's all thank Henrique. As I noted, this is going to be the video is going to be posted. We have a talk by Jamie McCusker next week. I don't have his. I will announce what his final topic and title and all that stuff is on Friday afternoon. Following that, Sam is going to do a talk, and then Sabir is going to do a talk. So we have a good lineup for the next few weeks. All good stuff. All right. Have a great rest of your day, everybody. Thank you.
Thank you so much.